Okay, I am here to present an overview of the next project for 327, Project 2. Project 2 is right here. So let's go there directly. Here it is. And I guess maybe Project Vector Word Count Skeleton, I should probably open that as well. Let me edit this. There we go. There's that one, and I have one more that I want to look at. And there's one more project that probably pertains to this. And if you look at the course website, there is a project here, how to use string stream to parse a line from a file. Now, this is crucial to this project. It shows you how to parse each line in this file. So I'm going to also open this one in Eclipse as well. Right there. Okay, there we are. And that's it. And I don't have anything running right now, so I can clear all those out. Let's see. And all I care about are these two projects here. So I'm going to close. Open that one. And I want to close my unrelated projects. Get rid of that and get rid of that. All right, so let's go back to here. So once again, this is an important sample project to help you with parsing tokens out of a line from a file. But let's go back to projects page, and we're going to go to the project. And the GitLab server seems to be a little slow right now. So here's the project. And the README tells you what you're supposed to do. You're supposed to write a word count application which does the following. Opens an input file for reading, reads all the words from the file, and counts the number of times each word occurs and records this data to a vector. It's going to sort the vector, just exactly how I showed you how to sort on yesterday, on Thursday. And it's going to write this sorted vector back out to the file. So it's basically everything we've been doing in class: opening and closing files, reading files, creating a vector, adding some objects to a vector, in this case a struct, counting tokens in a file, which we haven't done, but there's a project that shows you how to do it, and writing it back out to a file. So the first thing that you need to be aware of is I've given you an entire project. The stuff that you have to fill out is stuff in these two functions here, arrayfunctions.cpp and fileio.cpp. So what you should do first is get everything in here, just get enough content to get your program to compile. So if I look at this project, and I haven't looked at this, I don't know if there's anything else inside of here. Nope, there's nothing in here. And here's where fileio.cpp is. And I think arrayfunctions.cpp is right here. There's nothing in either of them. So you have to put content in here. What's the content? Well, go here and just go to the associated header file for it. The header file for fileio.cpp is right here. Notice in here, I've got a bunch of instructions. So here is what you're supposed to do. I want to open a file here. Here's the open it as an F stream. Now this is an F stream, not an IF stream. Since the F stream, you need to open it and then tell it how you want to open it. It will default to opening for input. And also this is a default parameter for open mode. You can have this default parameter only in the header file. You don't put it in the CPP file or else your program's not going to compile. Close file is going to check this file stream, and if it's open, it's going to close it. Write to file will take this standard vector of entry objects, and it's going to and a output file name where I want to write this to, and it's going to take that vector and it's going to write it to the file. So that's all you have to do for fileio.h. For arrayfunctions.h, it's a little more complicated. First off, notice that the arrayfunctions.h is in namespace KP. This will take it's going to take I've got some stuff to do. I've got a clear function here. Clear is going to take a vector full of these entry structs. I mean, what's an entry struct? If you go to the declaration for an entry struct, this is inside of constants.h. There's the struct. This is what you're going to use to track each word. There's a word uppercase, and there's the number of occurrences that has occurred. The uppercase, it can be uppercase or lowercase. It's up to you. This is so that you can have, you put the case for words. I can have the with a capital D and the with a lowercase d. So what you want to do is you want them both to be considered the same word. So when you're going to check inside of the vector full of entry structs to see if the is there, whether it's uppercase T or lowercase t, you're going to take the word you're searching for, you're going to uppercase it, and you're going to compare it to your uppercase version of the word. And that will tell you if it's there or not. And if it's there, you increment the number of occurrences. So what clear will do, and let's start with clear. Clear is going to take what's inside of this vector, and it's going to remove all the elements from it. It's basically calling entries.clear. This is going to tell me how many unique words are in the vector, basically the size of the vector, because you're going to have one entry struct in the vector for every unique word. This is going to get the location at a particular word at this location I out of this vector I, and it's only going to do it if and only if I is less than size of the vector, and that's the size of the vector. Otherwise, it's going to return the very last word in the vector. All right, this function will get the number of occurrences at a particular location. I'll pass in this entries vector, and I'm going to say, hey, give me the number of occurrences of the particular word at this location. And well, so this gets the word at that location. This gets the number of occurrences at that location. And then I have these three functions that work together. Process file will take a vector passed by reference, and I'm going to take an F stream, which is going to be an open file. So what this will do is it's going to loop through this file one line at a time, and it'll pull in one line at a time. And for each line, it's going to call process line, passing it that line. And what process line will do is take that line and extract all the tokens from it and feed each token to the process token function for recording. So it's going to loop through that line, get all the tokens, and for each token, it's going to pass it to process token. What process token will do is it's first going to call strip unwanted characters on this from the utilities .cpp to get all the junk characters off the token. Things like extra commas or periods, it'll get rid of that. If the token's an empty string, then it's going to return, since we're not tracking any empty strings. It's going to keep track of how many times each token has been seen. In other words, it's going to look through the entries vector, which I pass in here, that holds these entry structs to see if the word that this token represents is there. If it's there, it's going to increment its number of occurrences. If it's not there, it's going to create a new entry struct, set the number of occurrences to 1, and push that entry struct onto this vector. The last function is sort. And so I'm going to pass my vector in. Presumably, it's got a lot of entry structs in there. And I'm going to give it a sort order. And this sort order is going to define how I want that vector sorted by. Notice that it says sort entries based on SO enum value. Now, hold on a second. Let me tell me I'm still in the call. All right, let me go back here and go back to here. All right, so it's going to based on the SO and num value. I mean, what is this? Well, you go to the definition of it. It's also in constants. So sort order, open the declaration. It's right there. I can sort the vector by none, which means I'm not going to sort it at all. I can sort it by ascending or descending or number of occurrences. Ascending is sorting alphabetical ascending. Descending is sorting alphabetical descending. I think one is A to Z and one Z to A. And the other one is sort by number of occurrences, which means sort by the words that occur the most to the least. And so when you go to this function, when you call this, you're going to pass in the value, and based on what enum you've chosen, you're going to sort this vector, just like I showed you the last time, which means you're going to have some comparison functions. You put the comparison functions inside of array functions.cpp. You just put them at the top and you call them when you're sorting. That's all you got to do. Now note that array functions.h is in namespace kp. Keep that in mind. Also, the only two files you can modify are array functions.cpp and fileio.cpp. No other files, because those are the only files of yours that I'm going to take. I'm going to take them and drop them on my project and run it. And when I drop them on my project and run it, it's going to generate an output. Now, if you want to see what the output looks like, well, first off, you can go and find the entry point for the project. So look under here under source. Here's the entry point. Let's see. There's a student name. Let's see. I'm gonna see if I'm passing in some parameters, a student name or not. Then I'm going to call run all test. And what run all test is going to do is we'll go to the declaration. This is my code. This is going to test all of your code. It's going to test process token first, and then process line, and then file open and then close, and test it as a system. And then it's going to remove all the file debris. And you can look at all these test functions here. So inside of, well, where's the tester? Testing right down here. Under testing. So test process line. There we go. So this uses, if you look up here, this is using some templates. So this is just like Java generics. It just makes it easy for me to grade some stuff. I can pass in dynamic. This templates type allows me to pass in different types to grade stuff. All I'm doing is generating the results. And so when you're running these tests here, when you call run all test, so if your project is failing, set a breakpoint here and see where you're failing. You start off with 1 point. First thing you're going to call is test process token. And this is going to run through your code. And it's going to create a vector. It's going to clear it. And it's going to make sure that the size of that vector is 0. And this is the first test. And then it just keeps going, running tests on your code. And it gets down to here, and it's going to test ascending. It's going to test descending, test number of occurrences. And so it's going to do all of these things when I'm testing process token. And when I finish with that, where's my testing again? Oh, testing is all the way at the bottom. I'm going to call test process line. And I'll step through here testing your process line. And then I'm going to test file open close. And I'll just keep going. And I'll run all of these tests on your code, adding up points. Now, when I'm finished, this is run all test is going to return the number of points that you have. When I return the number of points, it's going to output whatever your grade was. You notice that run all test returns all of your points. That's your grade. It's going to output it. You want to see what this is supposed to look like. I think I included a sample run here under data. So there's an empty file. There's a full, no, I don't want that. There's a full file. So here's a full file that has a bunch of stuff in it, just a bunch of words. And I want to run this through my word counter. Once I run this through a properly functioning word counter, meaning I've defined the functions in array functions.cpp and I've defined them in fileio.cpp, what I should get in my output should look like this. I don't. Okay, that is fine. Just do it with a current editor and stop asking me. And this is what it should look like when processed. Quit asking me. So I could, but occurred once, that's occurred once, all occurred twice, a occurred 3 times. And this is just full without it being sorted. This is this file if it's sorted. Apparently, I'm sorting by alphabetical here, high to low, A to Z. So these are just examples of what it should look like. The output, when you finish running this program, though, will be here. So you'll get a bunch of output when you run this. You should also get what your grade is at the end. So if you don't get your grade, that probably means that your program crashed. If it doesn't return a 0, that means your program crashed. Now you're going to run into some problems here. Oh, here's some output. Is there anything in here? Nope, there's nothing in here. So that's kind of useless. So what have we got going here? There's some stuff in utilities that is going to be helpful. There's a way to convert your strings to upper. There's a way to convert an integer to string, because this struct that you're using here, I don't know, where is it in constants? This struct has an int here. So you need to convert that int to a string. And here's a quick way to convert an int to a string. There is the thing that strips rubbish characters. There's the function that strips unwanted characters, and strip unwanted characters is going to call strip character to pull out particular characters. So this is going to look through a string. And the first thing is going to get rid of a /r. The next thing gets rid of a period, and then a space, and then a question mark, and then all of these things. So, and then I've got this does file exist, and you can use these or not use these. I don't care. They're just utilities to help you out. So that's basically the project. When you run it, you should get a grade back. If you don't get a grade back, you probably crashed. There's a couple of other things that you want to be aware of. This project here, test string stream, look at this project and go through it. See how it actually parses a project. And let's see if I should be able to build this with no worries. And of course, it's going to build it. And you see what I've got here? These are not errors. This is an Eclipse indexer error. All I need to do to get rid of this, because you can see that this thing has built. If you get an indexer error, all you have to do is index, rebuild, and you can see it rebuild, and it will rebuild, and these errors will just magically go away. So what this project is doing is I've got this file that I want to open, and I want to open, there's my end file. It's going to be an IF stream. I'm going to open this file which is called my file, which is data.txt, which is right here. And I am going to, if I couldn't open it, I'm going to return could not open file. Otherwise, I'm going to load it. And when I load it, I am going to actually stream the tokens out of this file. And this shows you how to do it. So that's going to be a useful project for you. Now, Project Vector word count has a couple of, they're not gotchas, but they're things that you should be aware of. Let me go back here. The things to be aware of are here, things to consider. If you're having trouble with test 30 or 32 and testing.cpp, set and hit a breakpoint at line 223 or 231. That's when tests 30 and 32 are. So you go here, you go to, oh my gosh, look at all this stuff that I have. I have to get rid of some of this. All right, let me close others. And let me go to the tester, which is down here. I want to go there, open it up, and I want to go to test 30 or 32. Control F, let's look for 30. And there's test 30. If you're failing a particular test, you set a breakpoint and you step in to see why you're failing. What I'm doing here is I'm calling a function called diff. And what diff does is I'm calling it here and here. If you look at this function, if you open it up, what it's going to do is it's going to compare your code, the output that you generate with the output that I expect. That's all it's doing. It's doing a character by character comparison. And it's running the diff command, which is default built into Linux. So it should be part of your install. If you fail this, step through it and see why. And very likely, if you fail this, what's happening is you want to look at the output file that you generate and the output file that it's being compared to, and see if you've got any extra carriage returns or line feeds or spaces in it. Because that's probably what's happening. Because you will fail the diff of these two files if you have one extra space, you'll fail. So that's how to debug test 30 and 32, which a lot of you will run into. The last parameter in open file is a default argument. Make sure that's only in the header file, not the CPP file. In the compare functions, pass by ref. Don't incur the cost of a copy. This is what I talked about on Thursday. Use the enums. Don't do this. Don't pass in a 0. Use the enum instead, because I gave you the enums for a reason. Inside of constants, you're going to see all this stuff as well. A lot of constants that you can use. So if you try to open a file and it fails, you return that. And these things here are being used by me. So, gosh, what else? Here's some files. A lot of this stuff is being used by my tester. All right, so let's go back to project 2 for just a second and finish up in the README. Let's see where to start. Define all the functions in arrayfunctions.cpp and fileio.cpp, just enough to get it to compile, and then start filling in the code and seeing if you're passing tests. Only make changes to these two files. These are the only files of yours that I'm going to test. How to turn a standard string into a constant standard string for file IO. Use the cstring method of string. Make sure you call strip unwanted characters. These are just helpful bits of advice to make sure your project goes well. And use string stream to parse each line that you pass in. Here's a bit of code that might help, but you can look at that project that I showed you here, which is probably going to be a little bit much more helpful because it's a working example of using string stream. Let's see. Please use the struct and constants to hold the token information. And the data folder is going to have sample runs information. And the way I'm going to grade your project is I'm just going to take your arrayfunctions.cpp and your fileio.cpp and drop them on top of my working project, and then I'm going to run it. The grade that you get is the grade that I'm going to record. If you don't get a grade back, that means your project crashed, which is not good for you. Don't worry about the templates that I have in testing. You don't have to even look at them. When you step through testing, you don't have to go into the templates. It's just C++ that makes my life easier for testing. Also, I'm using popen in testing. It's a way to run another process, which are some Linux cleanup code and a diff tool. And points are going to be awarded as per the project output. So this should be pretty straightforward for you. It's just a application of what we've been talking about over the past week. It shouldn't be hard for you. So you might want to, but you want to start early in case something goes wrong, and you need to ask me questions. And that's it. That's project 2. And so I hope you do. I hope this helps. I'll see you next week.